For the last few years, we've all gotten pretty used to AI as a chatbot, right? A helpful assistant. But behind the scenes, AI is getting a major promotion. It's moving way beyond just answering our questions and is starting to take action, conduct its own research, and even outsmart its own kind. So let's take a look at AI's new job description. All right, so here's what we're going to cover. We'll look at the rise of these autonomous AI agents. We're going to break down two incredible new systems. First, FizzMaster, which is basically an AI physicist, and then AdGame, a really clever method for making AI safer. And then we'll see how these two sides of the coin, raw capability and crucial control, are shaping the entire future of AI. So, to really get this shift, we need a new way of thinking about what AI can do. We're moving from these simple models to what the experts are calling AI agents, and these are systems that can actually perceive, reason, and act in their environment. Researchers have kind of laid out this roadmap for the journey. Level 1, that's the conversational chatbot we all know and use. Level 2 are the reasoners, they can solve problems. Now, level 3 is where it gets interesting. These are the agents that can actually take actions, like use tools or write code. And believe it or not, the most advanced systems are now pushing past level 3 and into level 4, the innovators, where AI starts genuinely help us invent and discover new things. And that brings us perfectly to our first case study, FizzMaster. This is a fantastic example of an AI agent that's been designed to tackle one of the most intellectually demanding fields you can imagine, theoretical and computational physics. I mean, physics research is famously complex. It can take months, sometimes even years, of just tedious calculations and coding to test a single idea. FizzMaster was built to completely change that game, to free up brilliant physicists from all that grunt work and, accelerate the path to real groundbreaking discovery. Just look at these numbers. Seriously. A task that would take a senior PhD student, say 1 to 3 months, like coding up some complex numerical routines, FizzMaster knocks it out in under 6 hours. An entire research loop, from the initial idea to actually validating it, gets crunched down from a totally unpredictable timeline of months into a single day. The jump in efficiency is just staggering. So how in the world does it do that? Well, the key thing to get is that FizzMaster isn't just another language model. It's got this dual capability. It can handle the really abstract theoretical reasoning, and it can write and execute code to check its own work. It uses a specialized, always-growing knowledge base called Landau. Think of it like a constantly updated physics textbook. Plus, it's designed with what its creators call a physicist mindset to tackle these incredibly long, complex research problems. The whole system is really a team of specialized agents working together. In the first phase, a clarifier agent refines a researcher's question, and a librarian pulls all the relevant papers. Then, during the main task, a supervisor manages the whole project, dishing out subtasks to a theoretician who does the heavy lifting of reasoning and coding. And then finally, the results are passed to a writer to generate a formal report. It's like having an entire automated research department in a box. And FizzMaster operates at 3 totally distinct levels. First is acceleration, where it just automates all the grunt work. Then there's automation, where you give it a hypothesis and it just runs with it. And then there's the most advanced level, autonomous discovery. This is where the AI can independently explore open scientific problems, come up with its own hypotheses, and then test them. That is a huge leap from AI copilot to an autonomous AI scientist. Okay, so we're building these incredibly powerful tools. But as AI gets smarter and more autonomous, the big question is, how do we make sure it stays safe? This brings us to our second case study, AdGame. And this one tackles the problem of jailbreaking, tricking an AI into generating harmful or unsafe stuff. The whole idea behind AdvanGame is to pit 2 AIs against each other in what's basically a controlled sparring match. You have an attacker AI, and its entire job is to come up with clever prompts to try and fool a defender AI. The cool part is, the attacker is constantly evolving its strategies to find new weaknesses. But how do they actually learn? Well, that's where a third AI comes in, the judge. After the attacker lobs a prompt and the defender responds, the judge looks at the whole exchange. It doesn't give a simple thumbs up or thumbs down. Instead, it provides a preference, deciding which of 2 responses was better or which of 2 attacks was sneakier. And that feedback is the secret sauce for training both sides. So, to put it a bit more formally, AdvanGame is a training method where the attacker and defender models are trained at the exact same time in this non-cooperative game. And the key word here is concurrently. They adapt to each other in real time. This isn't a static training process. It's a dynamic arms race that forces the defender to get tougher and tougher against an ever smarter opponent. Now, the research behind Act Game figured out there are 3 really critical things you have to do to make this work. First, you absolutely have to actively train a separate, dedicated attacker model. Second, using that preference-based feedback from the judge is way more effective than just giving a numerical score. And third, they use a specific technical method to keep the whole training process stable, which prevents the AI's learning from just spiraling out of control. So now let's kind of pull back for a second and look at what these 2 very different projects tell us about where AI development is today. It turns out we're pushing forward on 2 critical frontiers at the exact same time. What we're seeing are really 2 sides of the same story. On one hand, you have something like FizzMaster, the toolmaker. Its focus is all about discovery, speed, and creation, using AI to help solve humanity's biggest scientific challenges. And on the other hand, you have AdGame, the guardrail. Its focus is on safety, alignment, and defense, building the systems we desperately need to keep these powerful new tools in check. And it's this dual progress, this building of both better tools and better guardrails, that's paving the road towards more advanced AI. But it also shines a pretty bright light on the significant challenges that are still ahead of us. We have to be realistic about where things stand right now. Both of these systems have their limits. FizzManor is still bound by the knowledge and reasoning ability of its underlying model. And, yep, it can still hallucinate. Meanwhile, AdGame is mostly designed to defend against attacks a human can read and understand, not necessarily every possible technical backdoor. The work is definitely far from over. So, this is the crucial point, right? We are simultaneously creating agents that can perform autonomous scientific discovery, and at the very same time, agents designed to keep them safe and aligned. The ultimate question these projects leave us with is, how do we balance these 2 pursuits? As we build AI to be our partner, our toolmaker, and our innovator, how do we make sure it also learns the discipline and the guardrails to be a safe and responsible one?